Okay. Have you seen my slide? Could you see my slide?
Yes, miss.
Okay. Yes. Today we will study about force and motions, and actually, it's still related to our previous meeting. I mean, in the last week's meeting, I that we talk about motions and then what that's speed, accelerations, and etc. I think and I hope you still remember. Okay, and and today we will continue about force and motion. Yeah, motion need a force. Motion need a force, and maybe we can make a next conjunction. A force need energy. So that's why you can play in a football and all of the sport and in your daily life because we uh, use a force. Okay, we use emotion. The emotion need a force. So motion is actually is all around you. It's even inside you as your blood moves through your body. For every motions, there is a force. So, in this meeting, we will learn about the force that make things move, stop, and change directions or the speed. To make something move, a force is needed. Lifting, pushing, like in a slide, we can see the girls that pushing a car, and maybe also when pushing and pulling, it's are all force, right? And at times, um, a person provides the force. When you, for example, when you lift a stack of books and then maybe push a same as light a push a broken down car, or maybe pull a rope in a tug of war game, and then you are the force. And what else? Machines can provide force to create motions. Yeah, if we talk about machines, yeah, a huge engine can produce enough force to propel a massive rocket into what is it into the space motors into the space motors. So as you can see this rocket, because the machines can produce enough force to propel a massive rocket into the space. Yeah. So motors in a cake mixer, fans and blender use electrical force to make things move. Nature can also be strong force. Here, as you can see in the slide, right? Nature can also be a strong force. Breezes make leaves dance on the treetops, and then oceans waves make boats bob up and down. So force deep underground cause earthquakes, yeah, earthquakes that make the ground tremble. So at Earth's crust is made up from the moving plates. So Actually, this is the basics why the earthquakes is I mean the process earthquakes, yeah, the processes of earthquakes, yeah, because there is a shifting plates, yeah, there is a shifting plates here, there is a shifting plates, so the shiftings makes the earthquake, but for the I mean the how to say for the full description about it, actually, we talk about the physics geologists. Yeah, because if I had taught before that the physics taught there are three major. It is medical physics, is applied physics, and geophysics. And it's talk about geophysics. Yeah, if we talk about the motions of plates of the earth, and then we move to the laws of motions. Yeah, maybe you have still remember the story about Sir Isaac Newton. That Isaac comes from England, and instead of apartment, he chose to study math and science in London. So it's 27. Isaac did experiment with light. He was the first to suggest that light was actually made up all the colors of the rainbow, and he is now one of the famous scientists on of all of time, right? And another, and Isaac Newton have a lot of um, inventions in the world that people can use it and apply it in their life, and also for our right now. Yeah, talk about the laws of motions. Much of what we know about motions come from the scientists that who lived hundreds of years ago. They conduct tests on moving objects. Yeah, it's example. Then also British scientist Isaac Newton discovered gravity. So as you can see, there is a tree. There is here there is a tree, apple tree that apple fall in the ground. So it's related to gravity, and gravity it's one of invention. Uh, Gravity was implanted by Isaac Newton, and the invisible force that okay. Could you if you imagine that could we see the force? Yeah, even though we cannot see the force by our eyes, uh, we cannot ignore the statement. I mean, we sometimes I also ask myself why uh, we can mention this is a gravity. I mean, why we can mention it this is a force. I think it's invisible, yeah, but to make this statement to make sense, all of the scientists have make a proof by the mathematics calculations. Yeah, so that's why physics and mathematics have high relations, because in physics we not only we not only just say that, oh, this is a force, but you can what we can make but we cannot make the proof by the calculations, because it will be the real what is it statements. I mean it will make how to say calculations and then statements. So but in mathematics we don't need a statement. I mean we don't need a phenomenon. For example, 1 plus 1 is 2, but it will be general. But in physics, 1 plus 1, we don't have definitions. One plus is except one book plus one book equals to two books. So it's right in physics. But in physics, one plus one equals two. So it's no meaning in physics. I mean, it will be more simple to explain that. Be like that. So that's why it's similar to all of the inventions in the previous time. Okay, you may have heard that was sitting under the tree one day when a fallen apple, and then yeah, he hit him the head. So the story goes that this accident led him to discover gravity, but it's not just said it's a gravity without the proof by the calculations. I mean the formula. Like, and then Isaac wasn't really hit on head by falling apple. Isaac was not really hit on the head by a fallen apple. It's just a myth. But over time, he observed that objects always fall down toward the ground. So I think you also have observed. I mean, not observed, but it's the real fact in our life and all of the things in the world that you fall down. It will be. I mean, if you use something things if you use some things, it will be fall down toward the ground, and that led him to actually to discover gravity from the is from Isaac. Yeah. Next is continue about the Newton's law of motions in physics. Yeah, maybe we still remember again about the first law, second, and the third law. Yeah, the first law will be for example, yeah, if you have a body at rest will remain at rest, and the body in motion will remain in motions unless it acted over by external force. Okay, let's make to be a general. Let's to explain for one by one. Isaac Newton is known for his theory of motions, which explains how things move. That this part, if the first law says that an object at rest will remain at rest unless a force acts over it. For example, your bike will stay parked where it unless something moves. Okay, and the second part of this law states that an object in motions will continue moving in the same way unless a new force changes the motions, and it will keep moving at the same speed and the same direction. So your moving bike will continue moving at the same speed and the same directions until your pedal faster, cause and brake or turn. So that's why maybe you can think in why is it important to wear a seat belt. So think about Newton's first law of motions. Yeah, every object at rest or in motion has inertia. Inertia. Inertia is what makes an object keep doing what it's already doing. Yeah, inertia. You maybe also can find by yourself what's inertia and maybe find your formula. Yeah, actually today I do not give you all of the formula, but I will make you to. I hope you can understand deeply about the concepts well. Okay, move an object. Yeah, as I said, inertia. Inertia is what makes an object keep doing what it's already doing. An object an object at rest will remain at rest unless a force moves it. An object in a motion will remain in motions unless a force stops it. So Newton's first law of motion is sometimes called the law of inertia. So if you heard the law of inertia, so that is the Newton's first law of motions. Okay, and okay, I think it's wrong. Okay, wait. And then we move to the Newton's second law of motions. Yeah, there are three motions. There are there are three the law of motions. The first, second, and the third. And if we talk about the second, we will what is it? We will mention mass. Mass, the amount of matter. Okay, mass is the amount of matter in object. Okay, Newton's second law of motion deals with mass and motion. It explained that object motions depends upon its mass and the amount force need to move that mass. So, why it's easier? So, if we have questions, why is it easier to move a small rock than a boulder? Yeah, maybe anyone can answer my questions. Why is it easier to move a small rock than a boulder? Anyone can?
Can I answer it?
Okay, please. Alan,
Because
yes.
as we know from the second law equation, force
Mm-hmm.
equals mass times acceleration. There is
Yeah,
mass involved in the equation, so the mass itself will affect the force that we need to move the object. Thank you.
nice answer. Thank you, Ridwan. Maybe we can hear another response, or maybe we will increase the explanations from the Ridwan. Yeah, maybe in our daily we do not realize that actually it's actually a conceptual physics. We just do all of them, but we don't know it's a physics. Yeah. And now maybe I know now maybe when you was senior high school, you have also got it, or maybe you just got it right now. It's okay, but the most important that you know that yeah, all of the what is it, the small things, it's easier to move than the larger things. Okay, thank you, the answer from the red one. Yes, you're right. Actually, uh, if we talk about the formula, and then we make what is it? We make relations between the phenomenon, yeah, between the phenomenon and formula. It's really good. Yeah, it's better. It's better. So that's why mathematics and physics, as I said before, cannot apart. Yeah, since a border has a much more mass than a small rock, so much more force is needed to overcome the border's inertia. So actually, it's related to still related to the first law. So much less force is needed to make small rocks move, stop, or change directions. And then, and also you can see this train has a large mass and a high speed, so it has a lot of momentum, and it will take a very strong force to slow or stop this train. This law of motion also deals with speed. Okay, maybe one is a mass, second is speed. Now, speed measures how far something travels in a certain amount of time. The faster an object moves, the more force is needed to stop it. Uh, Maybe when you was a child, your childhood, I mean your childhood, if you run in faster, then uh, if you run faster and you want to stop it, it's like we cannot what is it we cannot how to say, we sometimes fall down, okay, because we cannot maintain our body to stop right in the place that we want to stop. So because this related that the faster an object moves, that the more force is needed to stop it. So if you don't have the more, if you don't have a high force, it's also, you will make a trouble to stop it. Okay, and another one, maybe you can think about a locomotive speeding down in a track. Yeah, it has a lot of mass and speed, so a great deal of force will be needed to overcome the inertia of the train's motions and make it stop. Momentum, yeah, here this related also that with momentum. Momentum is the amount of force in a moving object. The more speed and mass a moving object has, that the more momentum it has. So a small slow scooter can stop much faster than a massive fast train. Okay, that you have to remember that velocity describes an object's speed in a certain directions, but the scientists calculate momentum by using the formula that mass mass dot velocity equals to momentum. But I'm sorry, as I said, I don't give you a formula today. I just want to talk you about the conceptual. Okay, mm, next we will continue about the Newton's third law of motions. Yeah, the keyword, if we talk about the third law of motions, is actions reactions. if, if you make an actions, you will receive reactions. Just that, just remember that. Yeah, Newton's third law of motion says that for every force or actions, there is an equal and opposite reaction. So for example, so if you miss for example, if you leave a 9 kilograms a box, the box pulls down with the equal force of 9 kilograms in the opposite directions. So this law explains why a balloon full of air goes flying when you let it go without tying it. Air runs out the open end, and opposite force push on the far end of the balloon, making it fly. as, as air rises out of the open balloon, equal force push in the opposite directions. So you can try to find the direction. Will it fly? Okay, I think it's the simple explanations, the briefly explanations about the first, third, and the first, second, and the third law of motions. But if you have a questions, please ask me. You can say, Miss, I have a questions for it. Okay, next we will talk about the type of force. One is a gravity. Yeah, gravity. You've learned that people, machines, and nature can all provide a force. Here are three more force that you should be familiar with, gravity. Isaac Newton observed that all objects pull on each other due to gravity. His findings become known as the universal law of gravity, and the law of gravity depends on the mass of the objects and the distance between them. Greater mass have a stronger pull, and if they move farther apart, the pull between them get weaker. So that's why mass, distance, and gravity. Actually, from this picture, I have two questions. The first is in in which situations in which situation is the gravitational pull strongest, and in which situations is the gravitational pull weakest. Okay, maybe anyone can answer. Okay, which one is will be get the pull stronger? Yeah, in which situation is the gravitational pull strongest, or in which situation is the gravitational pull weakest? Anyone can answer?
Kak, sorry, I cannot see the slide. Okay.
Could you see?
Yes, I can see now. Thank you.
Yeah. So, um, in which situation is the gravitational force strongest, or and in which situation is the gravitational force weakest? And because uh, it's talk about the distance and distance and gravity. Anyone can answer? Okay, maybe you can keep it with questions and just find by yourself, maybe after this meeting, but because I'm not going that maybe it will be your questions in the midterm, and I don't know, maybe. Okay, let's. Okay, and then the next picture, imagine standing next to a tall building. Both you and the building have a mass, so you both exert a gravitational pull. The building has much more mass, so it pulls on you much more than you pull on it. However, both you and the building are standing on Earth. So planet Earth is a far more massive than either you or the building. So Earth exerts a much stronger gravitational pull and you and the building than you and the building exert on each other. So on Earth, an object's mass is a measure as weight. The greater the mass of an object, the more the force of Earth's gravity pulls on it, and the more it weighs. And from the next slide and from the next picture, for example, if you were maybe in a space twice as far from the center of Earth as you are now, the pull of gravity will be only one quarter as strong. You will still have the same mass, but you would weigh only one quarter of what you weigh on Earth. Yeah, it's one quarter. Now let's move from the Earth to the Sun. The Sun has much more mass than anything else in our solar system. It exerts enough gravitational pull to keep all of the planets from flying off into space. Instead, they orbit the sun. Okay? Remember that the distance is also important. While the sun exerts more gravitational pull than Earth, you uh, are much closer to Earth than to the sun. So Earth's gravity keeps you from getting pulled up the sun. So yeah, that's about the gravity. Okay. Next we move to the second types of force. It's frictions. Do you know that the rough surface exert more frictions against each other than smooth surface do? Putting a lubricant such as oil or grease between two surfaces will reduce frictions. Yeah, a lubricant. Yeah, lubricant is one of the way to reduce the frictions. But we can also find another way to reduce the frictions. Yeah, maybe you can find it. Talk about the friction. Friction is also is invisible force that both slow down moving things and heats them up. One kind of frictions you know well is a sliding frictions. When you rub your hands together, they create sliding frictions. These frictions produce a heat energy causing your skin to warm up. So, in a rolling in a rolling bowling ball has another kind of friction. There is a rolling frictions, and the rolling friction will slow down a moving object, but not as much as sliding. Uh, yeah, not as much as sliding friction does. Placing rollers under a box make, makes it easier to move a rolling to reduce the frictions. But maybe you can find a lot of what is it? A lot of a phenomenon of daily that also related to how to reduce the the friction. But I but actually we not only to just reduce the friction, we also need the frictions, right? For example, your shoes need a high friction. So maybe you can imagine if you're in how to say the part of down of the shoes. I don't know, but it needed frictions if you walk or maybe you run. And also another one about the friction, there is a fluid frictions. Yeah, there is a fluid frictions. Fluid friction happens when object moves through a fluid, such as water or air. You can move your finger through water faster than honey because honey creates more fluid frictions than water. Yeah, in physics, maybe we talk about viscosity. And engineers design airplanes to reduce a fluid reaction caused by the air. Fluid friction can help objects move more easily, such as a puck floating on air in an air hockey game. Yeah, if you have doing this, maybe think about it. Imagine that you want to race your friends down a snow hill. How could thinking about friction help you win the race? Yeah, maybe you can imagine. Okay, quick repetition. We move to magnetism. Types of force. magnetism. Magnetism can push or pull objects made of certain metals such as iron. Magnets magnets also push and pull each other. So the force of magnetism can move objects without touching them. How? Invisible line of force. Answer: and leave it opposite ends or poles. Yeah, maybe you can. I don't know. Have you heard about the magnetic pole and a monopole and etc.? But yeah, there is a pulse. There's a board of magnet, and the magnet attracts a certain object that enters its magnetic field. Each magnet has a north and south pole. Two opposite poles attract each other, but two of the same poles repel or push each other away. It is opposite and repel. Okay, next we move to force, motion, and work. So in science, work happens when you move something, and the amount of work you do depends on the distance the object moves and the force it takes to move it. So it's if there is a questions, what is the relation between force, motion, and work? Then also you yeah, you can know that that scientists measure work by multiplying the distance an object moves by the force used to move it. Force multiplied to distance equals to work. Okay, from the picture you can say that there are a picture that it takes like walks to push an empty stroller, then a stroller with a baby in it because an empty stroller has less mass. Also, pushing the stroller 4 blocks require twice as much work as pushing it only 2 blocks.
Uh, okay. Uh, 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 Before I cannot see the PPT, but now I can see it. Okay, thank you.
Okay, okay. Yes, there's a questions about this. Yeah, that's why mass is I can say that mass is have the most role, the most important roles uh, for the motion because if we have a less mass, if we have a large mass, we need a high force. But if we have a large mass, we need a height, of course. Yeah, it's it's why force, motions, and work it's a really related, and definitely it's we already use all of the activity that similar for this similar to this how to say this term. Yeah. As I said before, that the force is a needed energy. So maybe you can remember there is a two kind of energy: potential and kinetic. There is a potential energy and kinetic energy. Anyone can explain to me what's yeah, first explain to me in briefly what's the difference between potential and the kinetic energy. Anyone can explain to me what it's uh, potential energy and what is kinetic energy. But please give me please do not give me a formula, but just a conceptual. Anyone? In
Can
brief,
I try to answer?
yeah, please.
Um, from my understanding, potential energy is an energy when an object is static. So it's based
Yeah.
on the position, and for the kinetic energy is an energy that was in an object that's moving. That's from my understanding.
Kinetic. Okay, kinetic is moving.
That's the main difference.
Okay, good. Anyone? What about the others? What about the others?
I wanna try.
Okay, please.
Potential energy is when a an object stored an energy but haven't moved yet, and if the
Mhm.
potential energy is released, the potential energy changed into kinetic energy and make the object move.
Okay, thank you. What about else? Okay, thank you so much for your answer. It's a really nice answer. And I hope another student here also understand what is it. Yeah, actually in our class, I mean in Mr. Arif class and Fahrudin class, also make what is it? Have informed to us that you have to understand the conceptual, right? So if you don't have if you have a question about the conceptual, you can ask me directly. Not just not only today, but I'm I'm waiting for you uh, in every day, in every day, yeah. Because um, I really like the students that have a high excited to know, but it's depend on you. If you have understand, alhamdulillah, it's a great actions. But if you still don't understand, please feel it to ask me. Okay, energy, yeah, energy comes in two basic types, yeah, potential and kinetic. As you can see, take a rubber band, for example. When you pull it back, it has potential energy. This energy is stored and ready to use. And the further back you pull the rubber band, the more potential energy it has when you let it go. The rubber band flies away. And the potential energy changes into kinetic energy. And kinetic energy is energy and emotions. Okay, maybe you can also think about it. Why can a motorcycle that is out of gas be ridden? Be ridden. Think about potential and kinetic energy. And also, and what it else? Okay, can you guess which type of energy a tank full of gasoline contains? Fuels such as a gasoline have potential energy. Boiling gas to make a car move change the potential energy into kinetic energy. And what else? The food you eat also had a potential energy. Plants gather energy from the sun. Animals get energy from eating plants and other animals. When you eat food, you store up energy. Then that energy makes your heart beat and makes your lungs expand and contract. So that's why we as a human being we need a food. If you don't need a food, so that's why it's like you don't you cannot do anything in this world, right? And the other one, And the last, I think this is the last one. Yeah, it's the last one. We talk about the energy transfer. Energy transfer. As you can see in the picture, the energy stored in the batteries can make a toy move and make a sound. It can also be converted into light energy and a flashlight. If you have a flashlight, is the one that the energy transfers or convert that convert to the energy, the light energy. What other please answer. What other examples of energy transfer can you think of? Anyone can answer. What other examples of the energy transfer can you think of? Any answer? An answer. Okay. While waiting your answer, yeah. Energy can be changed or converted from one kind to another. Energy can also be moved or transferred from one object or place to another. Changing and moving energy is called energy transfer. Solar energy becomes a stored energy in the plants. When you eat, the stored energy in plants can be transferred to your muscle and convert into motions in your arms. So you can, what is that? You can write in your computer. You can you can play music and others. Another example, the activity you can make gets the energy. Then these motions can be transferred to moving, for example, drumsticks, as that, you can see in a slide. Then these motions, yeah, these tricks can make a drum vibrate, creating sound energy. We, because because of you, because of you. it's like it's like a it's like a sound. Okay, the energy is a really important in our life. Without energy, it's like people die. But uh, but please use energy to be wise. Okay. Okay. For conclusions, I think you've learned that it takes force to make things move or stop, and that force affect the speed and directions of moving object. Uh, you read about Isaac Newton's law of motion. You learn that the mass of an object is related to the force that makes it moves. The simple push and pull, as well as the lifting, are example of force. So, and other types of force include gravity, frictions, and magnetism. People, machines, and nature can all exert a force. Work is done when a force moves on a check over a distance. So it takes energy. It takes energy to do work. And this energy is either potential, is a store, and kinetic is a motions. Energy can transfer by moving or by changing from one type to energy to another. Yeah, from one type of energy to another. Force and motions are in everywhere, all around you. Okay, I think it's my explanation today about force and motions. And if you have a questions before we close our meeting today, please ask me. There's a questions. Is there a questions?
Excuse me, can I ask you about
Okay, please.
the about the midterm UTS for next week.
Oh yeah, about the academic term.
Uh, does the question for physics gonna be about with essay or optional ini pilihan ganda?
Optional question. Uh, Actually, for 2 years, yeah, I mean, uh, in pandemics, I haven't seen the type of the type of midterm, but based on my experience from your senior, there are two kinds because actually UP1 and UP2 they are two lecturer. This one is a Mr. Fahrudin and Mr. Arif. Sometimes, and I don't know exactly, sometimes they combine the type of option of essay and the optional question, but sometimes it just essay and also sometimes conditional. But do not be afraid because as I said you in 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 physics class for EU, I think there is no more high formula there is no high calculations. It's just a standard calculation if you got it, if you got it. But the most important that you have to understand is the concept one, because for example maybe they will ask you like directions, and then there is maybe a fact there is a factor, and then they will ask you about it's built to the right side or to the left side, so you have to understand clearly about the factors, because factors is a mathematics basics that we apply in our directions. I think like that. Anything else?